Hey, this is Mr. Boggs, and today we're going to talk about voltage, current, and resistance. All of these things can be found in electrical circuits, but it's kind of hard to, since you can't really see electricity, it's kind of hard to really understand how that works. And so to kind of explain that, I have an analogy that I'm going to use. And so it's comparing how the water in a water tower works compared to a circuit. And so if we look at this water tower up here, so this is a pretty cool looking water tower in Finland, but it works the same way that your water tower works in your town. And so at the top of the water tower we have all this water that's been pumped up to the top of it, and this water has gravitational potential energy, and so that potential energy is going to be used to help pump it to your house. In electricity, our potential energy is called voltage, and so that's represented by V. And so if you have a battery and you have a 9-volt battery, then you have 9 volts of potential energy. Current is going to be like the flow of water through the pipes here, and so current with electricity is represented by I. Resistance in the water is going to be anything that offers resistance to the flow of water. That could be it going into a smaller pipe. It could be anything clogging the pipe if you have some kind of buildup that's clogging the pipe and it offers up resistance. And resistance in electricity, that could be anything that offers up resistance to that electricity. So if it's smaller wires or the material that the wire is made out of, and resistance is going to be represented by R in this case. And so voltage is measured in volts, current is measured in amps, and resistance is measured in ohms. And all of those things were named after the scientists that figured some things out about electricity. But it kind of works the same way as a circuit here. And so today I'm going to be using what is called the circuit construction kit. And you can go online if you want to kind of mess around with this. It's at phet.colorado.edu. So let's pull that up here. And so whenever you get into the circuit construction kit, it's going to look something like this. This is the AC and DC construction kit, but today we're just going to use the DC part of the construction kit. And so I've already started to construct a circuit. So these are wires here. That's what the wires are going to look like. So let's add another wire in here. Let's put an ammeter in there. And so an ammeter measures amps, and so that's how much current is moving through those wires. Let's add another wire here. Make a nice little circuit. Let's add our battery, and so we can kind of show how much voltage there is. So that's the same thing. That's a 9-volt battery, so that's kind of you ever seen those square looking batteries? Same thing that you might see inside of your smoke detectors. And let's add another wire over here. And so if you know anything about circuits and batteries, you know that I'm about to do something bad. And so whenever I connect this, what's going to happen? We're going to get explode. We're going to short out our battery, and so that can result in sparks. Or you might explode your battery. So in the lab, that's bad. Don't connect the wires from the negative to the positive, or you short out your battery. And so let's look at the amps. What's happening here? So it's got our ammeter maxed out. So there's too much flow going through here, and you can see how fast those electrons are moving through the wires here. And you can read down here, it says simulation speed reduced to less than 1% of normal. So they've actually slowed that down to less than 1% of how fast those electrons are actually moving. But let's go ahead and split this right here and add, nope, I don't want to do that. Alright, so let's add a resistor. And so go ahead and do that, and now that's a lot healthier looking circuit there. It's not going to explode. So a resistor offers up some resistance to that flow and kind of slows those particles back down. So let's look and see what we have here. So let me, oops, that's not what I want to do. Show the value on that. Show the value on that. So we have 10 ohms of resistance. Now we have 9 volts. So this volts, we have our voltage or our potential energy. Amps, we have 0.9 amps, and that's going to be our current represented by I. And then we have our resistance, which is R, and so that's measured in ohms. And so now we can kind of talk about Ohm's law. Now that we have these three things in our circuit, we have our resistance, voltage, and our current. And so Ohm's law, we spell that O-H-M, so Ohm's law. And so if we actually wrote out our formula for Ohm's law, it's voltage equals our current times our resistance. And so in the book it might be rearranged a little bit differently, but it's the same thing. And so if we look at the relationship between these things, let's see what happens if we increase voltage. How does that affect the current? Let me take that off. So if we increase our voltage, what happens to current? So we go up to 50. It increases our current to 5.06 amps. And so what happens if we increase our resistance now? So change our resistance. If we increased our resistance, it slows it back down. And so the relationship between those, voltage has a direct relationship with current. And so what does that mean? If you increase voltage, you're going to increase our current. Resistance has an inverse relationship with current. And so if you increase resistance, then it's going to decrease the current. Or the other way, if you decreased our resistance again, what's going to happen to current? It's going to go back up. It's going to speed back up. Oh, gave no resistance. So if we go back down to 0, we're going to short out our battery again. So we got to have some resistance in there. And so to kind of look at that, that relationship between those and what to do whenever you get a problem with Ohm's law, let's go back to our presentation. Let's erase this. Go to the next one here. So we have, I like to use this pyramid. It kind of helps you out in knowing what to do whenever you get 2 out of the 3 2 out of the 3 things in Ohm's law here. So if we don't know voltage, but we know the resistance and current, we can figure out what voltage is. And so I'd like to just if you put your hand over the one you don't know, that'll kind of tell you what to do there. And so if we don't know voltage and we covered that up, and we know our current and our resistance, then we just multiply those. And so if it's going from left to right, we multiply these two to find that one. Let's say that we don't know resistance. So if we covered this one up, how do we find resistance? We take our voltage divided by our current in that case. If we don't know current, then we're going to divide voltage by our resistance. And so using this pyramid, it might help you guys to write that in your notes and have that available to you, and make it easier to solve some of those problems. But the best way to kind of use Ohm's law is to just kind of mess around with it. And so we can do different things in our construction kit. Let's split this. So we can add different things in here. We can see what let's put those back together. We can use a voltmeter and see how many volts are running through the wires at different places. So we can move these things around and it'll tell you how many volts you have. If we get rid of that, let's add a light bulb. Okay. Let's move this one up here and this one right here. And so we can actually see how it affects a light bulb. So we can increase our voltage or decrease our voltage, and it'll give us a brighter or not so bright bulb. We can increase our resistance, and it'll dim the bulb, or decrease our resistance. Put 0 on there. We still have resistance with the light bulb, so now the battery doesn't catch fire. So we don't even need a resistor in there now. But that'll help you hopefully with voltage, resistance, and current. And next time we'll talk more about how to set up parallel and series circuits. So I hope that this was helpful.